All right, so this lesson is on related rates, and the key thing here is to use the chain rule to work out related rates problems. Okay, so in reality, that's the key, the chain rule. Okay, so let's have a look at a couple of examples and see how this works. All right, so a balloon in the shape of a sphere, so that's really, really important, is inflating. The radius is increasing at a rate of 4 centimeters per minute. So right there we have a rate, okay? At what rate is the volume increasing when the radius is 3 centimeters? Okay, so there's the question. So we need to find the rate that the volume, so dV, increases. So rates, they increase over time. So how's the volume increasing over time? dV dt is what we need to find, okay? Now often, and more often than not, in these questions we need to form a little chain rule. So I'm going to go dV over dt, okay? Now we need something to put in here and here. That's the same thing. Now here it looks like that something will be radius, because it's talking about the radius. And here we got a rate. So that will be dr dt is 4. Okay? So dr dt is 4. So let's put dr there and let's put dr there. All right? So this is really good because we can just substitute this in for that over here. But we need to find something in terms of dV dr. Well, I know that V equals 4 over 3 pi r cubed, because that is the volume of a sphere. And if I differentiate that with respect to r, I can get dV dr. So let's do that. dV dr equals 4 pi r squared. Now this is really good because now I can have something in terms of dV dt. So I'm going to put this chain rule over there and I'm going to go dV dt. Now dV dr I have here, so I'm going to go 4 pi r squared times, I know what dr dt is, it's 4, so times 4. So I get dV dt equals 16 pi r squared. Now, what the question is what is the rate when the radius is 3 centimeters? So I'm going to sub r equals 3, therefore dV dt equals, and it's going to be, we've got to put 16 pi, and that's going to be times 9. So we end up getting dV dt equals 144 pi. Now it's a rate. Now volume, what do we measure volume in? Volume is in centimeters cubed, and the centimeters come from here. Centimeters cubed per minute. And the minute comes from here. So the main thing is that we've got to let the question do the talking, and that's the answer of that. All right, let's look at a past HSC question on this. All right. Now I'm going to give a recommendation. When you're given diagrams, look at the diagrams and read the question. Probably not good to read this yet. It's not bad to, but the reason I ask you not to is that it might confuse you. But if we're stuck with the question, so one of these two, then we can refer back to the question and to see if we need extra information. But let's see if we can answer it. Okay, 1. Use Pythagoras theorem or otherwise to show dl dx equals cos theta. Now, just to start off with, I'm going to write cos theta equals its adjacent over hypotenuse, and in this case, cos theta, the adjacent is x and the hypotenuse is L, so I'm going to go x over L. All right. I feel like that's going to be important. Now, let's get started. So Pythagoras' theorem is just c squared equals a squared plus b squared. So in this case, c squared is l squared, x squared plus 40 squared. All right? Now, L squared, yeah, that's really good. Now, the next thing I'm looking at is I'll need to find something dl dx. Now I can get there because I've got L and I've got something in terms of x. All right, well, let's do it. I need to square root this side. So I've got x squared plus, and let's write that out, 1600. And we know how to differentiate this. I have to change it to an indice. So all to the power of a half. Okay, now let's just differentiate it. dl dx equals half. Bring the indice, the power up. The brackets always stay the same. Minus a half, because that's minus half. And then we have to multiply by what's in the brackets. So, but the derivative of the brackets, so that's just 2x. And in this case, we can cancel that out. And we get dl dx is equal to, and I'm just going to put the x at the top, and the square root of x squared plus 1600 at the bottom. Now, I haven't quite shown this yet. But if I look at what I wrote at the start of what cos is, it's x over L. All right, do we have something in terms of L? Here. Oh, that's right. L, that's the same as that. So if I go, therefore, dl dx equals x over L. Therefore, dl dx equals cos theta as required. All right, so we've neatly done these questions. All right, I'm going to keep moving on, part 2. All right, so I'm moving on to part 2, and it says show that dl dt equals 3 cos theta. So I'm just going to write dl dt. I need to form a chain rule, so I'm going to go dl over dt, and I need something else. This one gives me a clue, dx, so I'm just going to put dx, and that's dx. And that's really good because I can just substitute this for this, and that gives me close to what I need to. So, but I also need to find dx dt. Now, if you look at it, in the question it says a truck moves left to right at a constant speed of 3 meters per second. Now, oh, that's here, and that's x. So therefore, dx dt equals 3. So now we can finish the question off. dl dt equals dl dx, that's cos theta. dx dt is 3. Therefore, dl dt equals 3 cos theta as required. And that's how we do rates. Let the question dictate what chain rule, what rates are available, and give it a red hot go. All right, that's the lesson. Peace out.